Today we're going to be looking at Learning Target 8M G Lt14. This is day 2 of I Can Verify Congruency through a sequence of translations, rotations, and reflections. We've already talked about the transformation translation, but now we're going to be talking about reflection. And reflections are flips. So translations are slides where a reflection is more of a flip. And so when we are reflecting, a pre-image and an image must be equidistant from the line of reflection. So equidistant, if we were to break that down, we have equi, and then we have distant. And all that really means is that the pre-image and the image are equal distance, or they are an equal distance from that line of reflection. So there can be an infinite amount of line of reflections. The main two that we're going to talk about right now are the x and the y-axis. So if the x-axis is our line of reflection, remember the x-axis runs horizontal on our coordinate grid. And so to reflect our figure PQRS across the x-axis, we need to make sure that our points are equidistant from that. So if I look at pre-image point P, pre-image point P is currently 3 boxes, 3 boxes above the x-axis, which means that the image of P is going to be 3 below. 1, 2, 3. So the image of P, I'll label with P prime, including that tick mark. Q, the pre-image Q, I can see is only 1 box away from the line of reflection. So when it reflects over the x-axis, it's going to be 1 box below. So we have the image of Q right there. And I'll do that for my other points. R is 1 square above, which means the image of R will be 1 square below. And we label that R prime. And then S is 1, 2, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Our image of S is right there. And then I can recreate my figure. And we notice that figure PQRS has flipped downward over the x-axis. So let's get our new ordered pairs here. So the image of P is at -2, -3. The image of Q is at -2, 1. The image of R is at -3. Oh, I'm sorry, it's -1, -1, and then -3, -5 for the image of S. So if I'm looking at those ordered pairs, I recognize, looking at my first ordered pair, -2, 3, and then my image of P is at -2, -3. The x values stayed the same. However, the y values all changed to the opposite values. So a quick trick to remember what's going to happen to the ordered pairs, or to help you graph an image of a pre-image when reflecting over the x axis is that your x value stays the same, and the y flips its sign. Or it flips to the opposite. When we're reflecting over the y-axis, so y-axis, remember, is our vertical axis, we're going to follow the same procedure that we just did. So P is 2 away from the y-axis, it's 2 on the left. So if I go 2 to the right, I get my image of P. And here I'm going to do a double prime because it's technically my second image of PQRS because in example 1A, I had my first image. So this is now the second image, so I'm going to be using double tick marks. Q is 2 to the left, so the image of Q would be 2 to the right. And that is Q double prime. R is 1, 2, 3 to the left. So 1, 2, 3 to the right would be my image of R. And then S is 3 to the left. And so 3 to the right would be the image of S. And I'm sorry, that's the double prime. So if we connect our points, I'm going to rewrite that P double prime so it's not through the figure. Okay, so if we look at our new ordered pairs, the double image of prime is at 2, 3. The double image of Q is at 2, 1. R is at 3, 1. And S is at 3, 5. So if we take a look at those, my pre-image is at -2, 3, and the image goes to 2, 3. Well, the 3 stayed the same. However, the x's flipped their signs. So when you're reflecting over the y-axis, the y stays the same, and the x flips its sign. So if we were to put that as a general rule, if I start with my pre-image point, xy, if I reflect it over the x-axis, the x stays the same and the y flips its sign. And we would indicate the flipping of the sign by putting a negative in front of it, just meaning the opposite. So it's the opposite of y. If I reflect it over the x-axis, the x is going to flip to the opposite and the y is going to stay the same. And if we do both, so if we reflect over the x and then over the y, or we reflect over the y and then over the x, so you can be considering it doing both, then both values flip to the opposites. Okay, so looking at our example here, number 2, says describe the reflection that maps QRS to the image of QRS. So I can see that my pre-image is here because it has no tick marks, and then my image is here. Okay, and if I am reflecting over the y-axis, let's see, so y would be here. If I were to reflect over the y-axis, my image would be in that first quadrant. If I were to reflect over the x-axis, my image would be in the third quadrant. So just from looking at this, I see that I had to do one more flip, which means that triangle QRS was reflected across the X and Y axis. So either both at the same time, or you can say it was reflected over the X and then the Y, or it was reflected over the Y and then the X. But I think it's sometimes easier to say that it was reflected across, you could even say both the X and Y axis. Now sometimes your line of reflection is going to cut through a figure. Okay, so it's not necessarily going to be a figure in one quadrant completely. In example 3 here, we have an example where the figure is laying over the x-axis, and our directions say to reflect it over the x-axis. So what I need to do is I'm going to look at my points. So once you have your points, you're going to identify the axis that you're reflecting over. So that would be my x-axis. And according to our rules, when we reflect over the x-axis, the x stays the same. So I'm going to make a note, x stays same, and y flips its sign. So with my points, if x stays the same, 1, 3, and 1 will all be the same value. And then looking at my y's, 3 would become a -3, 2 would become a -2, and -2 would become a +2. So now if I graph these, 1, -3 is here. So my image of J is below the x-axis, which makes sense. If the pre-image J is above the x-axis, if we reflect it over the x-axis, it would then be on the bottom. So then for L and K, since they are below the x-axis, when we reflect them over the x-axis or across the x-axis, they will then be above. So for the image of K, it would be at 3. Oh, just kidding. I caught a mistake. This is why I need you guys around so you can catch me sooner. So K is actually at 3, -2, which means that the opposite, the y flipped, would be at +2. So the image of K is going to be at 3, +2, the image of K. And exactly as we said, it's above the x-axis. And then the image of L would be at 1, +2. And notice that's over the figure that's already there. That's okay. That will happen, especially if your figure is being cut by the line of reflection. All right. Then we also have some additional examples. Just as I said at the beginning, your line of reflection will not always be the x and y axis. You can have an infinite amount of lines that you could reflect a figure over, and this is one of those examples. So here it says to reflect the following over the line x equals 1. Okay, so we need to identify what is the line x equals 1. So I'm going to look at my x-axis and I'm going to find 1. So x equals 1, oh, right here. So that means anywhere along that line, x is going to be equaling 1. So that would be my line of reflection according to this. That is the line x equals 1. So I'm going to be reflecting across that. The big thing to remember is that general rules, how big can I write this? The general rules do not apply. So as we were saying, if we reflect over the x-axis, the x stays the same and the y flips. Or if we reflect over the y-axis, the y stays the same and the x flips. That does not apply when your line of reflection is not the x or y axis. So please make a note for yourself, star that, make that really big so that you don't make that mistake. Okay, so if I want to reflect figure ABC across the line x equals 1, I'm going to follow the same pattern that I did in my first couple of examples. If I look at A is 2 units to the right of the line x equals 1. So the image of A is going to be 2 units to the left. So this would be the image of A. B is 1 unit to the right of line x equals 1. So the image of B is going to be 1 unit to the left. Make sure you label it correctly. C is 1, 2, 3, 4 units to the right. So 1, 2, 3, 4 units to the left would be my image of C. And there I have reflected my image across the line the line x equals 1. So if I wanted to just see, there is not really a pattern that's going to be occurring with the ordered pairs, but we're just going to prove that here. So we have 3, 4 for my pre-image A, 2, 2 for my pre-image B, and 5, 1 for my pre-image C. And the reflection over the x equals 1 line, A is going to be at negative 1, 4. B is going to be at 2, B is going to be at 0, 2, and then C is going to be at negative 3, 1. So you will notice that the x values stay the same, okay, but that's not following one of those general rules. But it should stay on that same x or y line if you're reflecting over that x equals. Okay, so go ahead to your homework and leave some questions at the end of this video so we can go over them tomorrow. Thank you.